Let's talk about factoring quadratic trinomials. First, what are quadratic trinomials? These are expressions of three terms, constants, x, and x squared. And also include the coefficients of x and x squared as using a to be the coefficients of x squared, b is the coefficients of x, and c is the constant, which is the third term. So if these expressions can be factored into two factors of binomials, which is in this form, then we will have two factors. The first factor of binomials of the terms where you have two terms, x and a constant, you have dx times a constant e, and the second factor to be x plus the constant g. Keep in mind that d, e, f, and g, they are constants that we're looking for in order to complete this factoring process. Right? Now, rewriting the two factors on the right side, if we are do a foiling step, we'll gather that for the x squared term, the coefficients of x squared is d times f, and multiply by e times fg, e times fx, you get efx. Next step is multiplying dx plus g, you get dgx, and lastly, multiplying eg, you get e times g. So gathering all the coefficients together, see that the coefficients of x squared in terms of df, def, is df. The coefficient of x in terms is ef plus dg, and the coefficients of the constant is going to be equal to e times g. Comparing these expressions with the original expressions, we'll see that for the factoring, this factoring works, d times f has to be equals to a, and ef plus dg has to be equals to b, and e times g has to be equal to c. All right. Again, d, e, f, g, they are constants that we're looking for. Now put it all together in one place. If you're given a trinomial in this form, quadratic trinomial, and if these expressions can be factored into two factors of binomials, then these three conditions have to satisfy. So d times f has to be equals to a, ef plus d times g has to be equals to b, and eg has to be equal to c. Now let's look at an example. You have 2x squared plus 3x minus 5, and if this expression is factorable, then we're going to write down the two factors on the right side. Okay. Now going through the first step, we want to identify a, which is 2, b, which is 3, c, which is negative 5. Remember, you have to carry the negative with you. Now, using the first conditions, df equals to 2, ef plus dg equals to 3, eg equals to negative 5. Going through the first conditions, you want to find the two numbers such that the products of these two numbers is 2. So first you have the first pair, which is 1 and 2. Second, negative 1 or negative 2. Then I'm going to jump to the last condition, which is the products of e times g equals to negative 5. So then the possible pairs are 1, negative 5, and negative 1 and 5. Now the second condition is a little harder to check because you have to use the possible values of df and eg in order to make up these equations. So then let's go through the first pair. So pick a pair from DF and a pair from EG to do this. And keep in mind that with this setup, you see that in order to check this second condition, you just need to line up the pairs and then do the cross multiplications. So you're going to take D times G plus E times F, okay? And if it's equal to 3, then you will pick the two pairs. Try the first pair. See that you take 1 times -5 plus 1 times 2, you get -3. So -3 is not the right number. But we see that, okay, well, we're almost there, right? So the sign is opposite, but the magnitude is about the same. So 3 and -3. So maybe we just need to switch the sign of one of the pairs, so that would work. So let's go to the next pair. I'm picking this pair and this pair. So you go from 1 times -5 plus -1 times 2, and here we go, it's equals to 3. So these are the correct pairs that we're looking for, right? Because this pair work together will give the second condition. Now, using the first pair for D and F and second pair for E and G, plug it in this templates here. Now, D is going to be equals to 1 and F is going to be equal to 2. Replacing 1, 2. E now equals to -1 and G now equals to 5. Replacing -1, replacing 5. You successfully factor this quadratic trinomials.